Okay, general science, this is experiment 13.3. It's very similar to 13.2, looking at the role of Tums in your stomach acid. So this time we are going to be looking at the role of baking soda, or sodium bicarbonate is what we're looking at it chemically. And this is produced from your pancreas, or something very, very similar in your pancreas, and released into your small intestines. So we're going to look at what that does to stomach acid. So we are again using the Works toilet bowl cleaner as our stomach acid. And we are using our indicator, our pH indicator. This is like the pretend food that's in your stomach, you know, or shoot, if you drink purple soda, it'll probably look a lot like this. So we are going to see the role of that in our stomach. Okay, so we're going to add about a teaspoon of this. This is our stomach acid. You could totally do this experiment at home if you want to. The pH indicator, if you don't have red cabbage, it doesn't have to change color. You could still do this. You'd see bubbles, maybe. That'd be about it. You wouldn't have the cool color change. All right, so we've got our stomach acid, swirly swirl. And now we are going to be adding some baking soda, seeing what happens, how it's similar or different to our Tums. Now, the nice thing with this is I don't have to pretend chew it because it's in powder form. Oh, that's awesome. Okay. So don't do this at home. Don't do it next to your computer because that's where it's headed right now for me. Whoa, what a mess. Oh, shoot. Okay. So maybe I used a little too much baking soda. Probably would have done that in class anyway, but I would have to mess up the school. Hopefully you can see that all of this powder changed the color of my indicator. Let's see here. All of this gross juice all over my table here is purple. Hopefully you can see that. Let me give you a good look here. Okay, so you can see our indicator. Oops, sorry, got you upside down. Hopefully you don't get seasick here from this activity. It's a really dark color. Wow, I got a movable camera. Hopefully you don't get sick. It's a purple. It's a very dark purple. This changed that bright pink into a dark purple with like a half a spoonful. Okay, so we had baking soda interact with our stomach acid, and this neutralized it. So what's happening here is I want you to tell me how this is similar to these. How are they similar in their function or in their reaction? Now, big picture, what is this representing in the digestive system is we have all kinds of acid in our stomach, and our stomach is designed to handle acid. It literally makes acid, and acid is in it all the time. You have this, you know, that slimy lining all the way around your stomach, which you read about, hopefully. It protects the stomach. But the problem is your small intestine does not have that slimy, safe covering. So when the stomach acid or the chyme is ready to go through that small intestine and go through that, that sphincter, the duodenum, I believe, into the small intestine, it needs to be neutralized. And that's the role of the pancreas. It squirts some of this stuff in it in a sodium bicarbonate form, neutralizes it. So now it can go through your small intestine without eating holes in it with this really strong acid. If you do try this at home, wear some gloves or just be really careful. Don't let it get on anything. It needs to neutralize the food so that it doesn't eat a hole through your small intestine. And then your small intestine gets to do its job, which you'll be reading about soon, pulling out some nutrients. So if you have any questions about this lab, of course, ask, but you're answering the question, how are these guys similar? And you're going to use evidence from the lab to prove it.